Hello, boys and girls. This is just a quick and dirty gas law introduction. We're going to be looking at the things we need to understand before we ever get to the formulas for gas laws. If you understand these three things we're going to cover right now, then it'll make it really easy for you to do the the formulas in the next lesson. But first of all, gas laws. Hopefully you're thinking of three things when you hear of gases, or three things that affect gases. And the first one would be volume. So if you look at how we're going to measure volume in this lesson, we normally use either milliliters or liters. Remember, there's 1,000 milliliters in 1 liter. So those are a couple of things we'll be using for volume. Occasionally we may use a centimeter cubed. Remember, that's the same as a milliliter. All right, so the next thing we'll be looking at is temperature. So the temperature, I'm going to abbreviate there. We cannot have a negative number whenever we do some of the formulas. So because of that, they're going to change degrees Celsius into something called Kelvin. So when we add 273, just 3 sig figs there, we're going to get Kelvin. Kelvin is not in degrees, it's just a capital K. So please remember, whenever we're doing formulas with temperature, we're going to take the Celsius and do what? The little acronym I tell kids to remember is when you see the C, add 273. So that's something that can be helpful. But make sure we do that throughout the next lesson this week. Whenever you're trying to go from Kelvin back to Celsius, of course, you would just subtract. So now, the last one we're going to look at is pressure. Now, pressure is going to be so important because it's measured in like 4 different ways. So these 4 different ways, we're going to grab the printout from the internet. If you don't have a printer, that's fine. You can just write this on paper. But pressure, we're going to jump to this sheet. Pressure can be measured in several different units. They are: atmospheres of 1 atm can be found at sea level. This is all over the world. Anytime you're at the beach, you're at sea level. So right where the water touches the land. All over the earth. That's 1 atmosphere when you're at the beach. All right, that 1 atmosphere can also equal 760 millimeters of mercury. Mercury symbol is Hg. That means it lifts 760 millimeters of mercury up in the air. It's how much air pressure we have around us. Next thing is 1 atmosphere equals 760 torr. That's short for torque. If you've ever rotated your tires, you're supposed to torque in the lug nuts. So that makes it real there. Last thing, 1 atmosphere equals 101.3 kilopascals. That's little k PA, which you could have just wrote out kilopascals. Okay, so those are the 4 different ways we'll be measuring those: atmosphere, millimeters of mercury, torr, and kilopascals. We're going to look at some conversions right now before we ever start the simple gas laws. You need to be able to convert these. We'll do those in just a second, but first, why do your ears pop? To make this real, why do your ears pop when you go up Highway 26 to Hendersonville? Maybe going to Asheville. Well, remember, as you go up the mountain, it's kind of like the Kings Mountain swimming pool. So I'm going to try to draw a rendition of the Kings Mountain swimming pool here. There we go. If we held you down in the 3 foot, here's the water line. So if we held you down here in the 3 foot for 5 seconds and asked you to come back up and tell us how your ears felt, you would probably say, hey, it's not bad. But then what if we threw an anchor around you? Sounds scary. Threw an anchor around you for just a second, let you hold on to it to pull you all the way to the bottom of like the 12-foot area. How do your ears feel at the 12-foot area? Obviously, there's a lot more water on top of you. Think of all the pounds of water that's on top of you pushing in. So that means there's more pressure on you here. Well, same thing with air. Air where you have more of it on top of you would be the beach. So I'm going to try to draw like mountains. And then you have a few foothills. And then you have all the way down to the beach. So at the beach, you've got like the deep end of a swimming pool, you got a lot more air on top. Here in the mountains, you'd have less air. So now back to our question. Why do your ears pop when you go up Highway 26? There's actually less air pressure on top of you, so the air behind your eardrums is trying to get out. If you chew or gum or make like you're yawning, it'll move your bone that's attached to your eardrum and help vibrate that just enough to let the air pressures equalize. Okay, how much pressure is in 1 square inch on your skin due to air pressure? And the real number is 14.7 pounds per square inch. A lot of times most people just round that to 15 pounds per square inch. Right now I'd love for you to work a few, after this couple of conversions here, I want you to go to the video and watch 2 air pressure videos. So I'll have those linked to the lesson as well. Okay, let's go ahead and try one of these conversions down here. Actually, we'll do all 4. And that way all you got to do is copy it down and have this sheet done. So we got 2.5 ATMs. Draw our factor label. We've done that a lot, right? Now, how many millimeters of mercury are in 1 ATM? Well, I'm going to go back up to the top and see that there's 760 millimeters of mercury in 1 ATM. 1 ATM on the bottom, so it'll cancel out. 760 on top. So what do I type in now? Hopefully just the 760 times the 2.5. And you get 9,400. All right, let's try the next one. 506.5 kilopascals. Okay, how many kilopascals are in so many torr? Well, if we look back at the top, we saw that 101.3 kPa is in 760 torr. If you lose this sheet, don't worry. This is all right off your reference packet too on the front page. 760 torr, 101.3 kilopascals. Now, how do we type this in? 506.5 times 760 divided by 101.3. And make that 101.3. And that number is 3,800. Okay, so I'm going to leave you 2 to do. That was a pretty easy conversion. Don't forget, be sure to go in and watch the fun implosion of a can and, of course, the blowing up a balloon inside of a flask. Those are 2 really neat demos I hope you watch. Thank you, and we'll see you soon with gas laws.